So when most of us went to school, pages of sums were the go. Even in the workforce, sums were done on paper. Nobody for a career these days does pages of sums. It doesn't happen. So we have to have a different expectation. We have digital technologies. If the numbers are too large, let's reach for our mobile phone. Let's use a spreadsheet. What we're doing is we're laying down a really solid foundation for mental computation. Even the receptions, they'll be looking at a dice like this, and we expect them to subitize. That means to suddenly know that there's 4 dots on that face. Or if I turn it over, that there's 3 dots. They don't need to count, they should just be able to look at that and visually know how many dots they're looking at. So once we can subitize, at least to 6, the numbers on the dice, we can start to use 2 dice, for instance. I can subitize 4 and know there's 4 there, don't need to count those, and now I can go 4, 5, 6, 7. So right down there at reception, that's what we're expecting students to do. If I turn these over, I've now got double 6. Double 6 is 12. We should have instant recall of that by the end of grade 1 at the latest. I'm going to put 3 dice into the mix, and I'm going to actually fiddle here, because if I put a 6 with a 4, that's the rainbow fact. By the end of grade 1, students should instantly know I've got 6 and 4 more, that makes 10. And if I throw a 3, 10 and 3 more is 13. 10 is a friendly number. Not much work to do to add 3 onto it. We don't want to see the children going 10, 11, 12, 13. We want them just to know. I can put 4 dice into the mix, and I can move the dice around. We want the students to know you can add these dice in any order that you like. I'm still going to find my 10. 6 and 4 is 10. And 3 and 2, that's the count on that makes 5. There's my friendly number 10, and 5 more is 15. Instant recall, building up just like that. Most homes have dice. They have games that have dice with them. Children are learning a lot about their number facts simply by playing with dice, but of course we can make up simple dice games. I might decide to throw my 2 dice over here, and I've ended up with a 5. My child might throw 2 dice over here, they've ended up with double 6, which is 12. The larger number wins, so obviously 12 scores a point. Just try again. Can you see a double?
Yes.
Right, what's your double?
6.
When students are a little bit older, when the children are a little bit older, they can play with 3 dice. Now we're going to play a game called Target Number. 2, 3, 4 players. When you throw the 3 dice, you can arrange them using addition or subtraction to get as close as possible to a target number. So supposing my target number was 9, and I throw the dice, and that's how they've landed. I know I've got my rainbow pair there that makes to 10. So 10, count back 2, is 8. I think that might be as close as I'm going to get. So I'm quite close, but then here's the child's turn. Let's see what they get. I'll look at that. There's the near double, 4 and 3, that makes 7. And 2 more is 9. Obviously the child won that time.
8, 3, 10, 11.
Teachers today are picking up some of the things that used to happen in the home. It used to be the case that children would come to school, they could subitize, they could do some simple additions. They played games like dominoes, cards, endlessly. I bought these dominoes for $2 in the Dollar Dazzler shop the other day. Just supposing I played a simple game, we're each going to take 1 domino. I've taken that one. I've got the near double, 4 and 5, which makes 9. Let's see what the child got. The child got double 1 is 2. If we're playing for the highest domino, I've won. If we were playing for the lowest domino, I've lost. Let's do that again, but let's choose first. Let's play for the highest domino. I'm going to pull 2 to the side. Double blank, that's nothing. 3 with a count on 2 is 5, so I lost. Silly little games like that. Supposing we were to take, I'll shuffle them around a bit, supposing we were to take 2 each. Supposing closest to 10 was going to win. What have I got? I've got that blank again, and 5 and blank, I've only scored 5. Let's see what the child got. 6, and 1 more is 7. So clearly I lost again. The new Australian curriculum is asking us to develop adaptive reasoning with our students and to develop problem solving. Even young children, before they come to school, can start playing some simple adaptive reasoning games. For instance, I've just grabbed a handful of toys here. Now I might say to the child, I'm thinking of an animal that has a very long neck. What is it? It's the giraffe. I'm thinking of an animal that likes to float on the water and goes quack. What is it? It's the duck. In the real world, when we do problem solving, there's often more than one right answer, and there's always more than one route to the solution. So we're sort of covering that, taking a risk here. And now we're ready to play a game. So I've chosen one of these objects, and the child's job is to ask me which object I've chosen. Now questions could be, is your object yellow? No, it isn't. So what do I need to remove? The two yellow things.
Find me a toy that makes noise.
That one and that one.
Okay. Next question.
Is it wooden?
No, it's not wooden.
Is it green?
Yes, it's green.
Most homes have a pack of cards in them. Some of you might remember playing solitaire as a child. One of the ones that I used to play endlessly as a child was one where you put out cards, you put 9 out at a time, in 3 rows of 3. Now I've removed all the picture cards and all the 10s, which means that I can make pairs that add to 10. So what I've got to do is I've got to look down here. If I have a pair that adds to 10, there's the 9 and the 1, the rainbow fact, that makes 10. There's the 5 and the 5, the double 5, that makes 10. And that's it. I can't remove any other pairs, so I've got to fill the gaps.
Aces or fill the gaps here. Right.
For many of us, we were only ever taught one way to solve a number problem, and generally we use this strategy in our heads, even when it's inefficient. So for instance, when we see 27 plus 24, we add the 7 and the 4 and then carry the 1 to the doorstep. And then we add the 2 2s, which are really 20s. The problem we have with this method is that children are not actually using place value. What they're doing is what's called digit-based addition. They don't realise that they're adding 20 and 20. They just see them as 2 2s. Here are 2 other methods for adding that enable children to understand and develop place value. The first method is called number splitting or chunking. Here, to add 27 plus 24, we add the 20 and the 21st. That gives us 40, and the 7 and 4 makes 11. That's 40 is a friendly number, easy to add on to, that gives us 51. Another method is called balance and compensate. So for 27 plus 24, if we add 3 onto the 27, that gives us 30, but now we need to take 3 off the 24, which leaves us with 21. 30 is a friendly number. 30 and 21 can be done in the head, and that gives us 51. It's really vital that children can explain their thinking. They can tell us how they've done something, and that they can select from a range of strategies the one that is most efficient and works best with the numbers at hand.